Alright, we're going to be doing the elimination method today. The steps to the elimination method are 4 steps. Write both equations in standard form. So in other words, you want an x plus a y, then equals 2. So ax plus by equals c. Once you have them both in that form, you do step 2. Eliminate one of the variables and solve for the other. Sometimes this is a real easy step. Sometimes it has a couple pieces embedded into that step that we're going to have to do extra. Number 3, once you eliminate one of the variables, you're going to solve for the remaining variable. It's going to be left over, so you're going to substitute that one back into the first equation so you can find the last variable. Step 4, you write the ordered pair. Now let me show you what I'm talking about by giving you an example. Here's a good one. First thing we have to do is see if it's in standard form. So are they both in x, then a y, then a equals 2? Yeah, they're both in that form. So now we're going to eliminate one of the variables. So I'm going to rewrite them. X minus 2y equals 19, and 5x plus 2y equals 1. How you eliminate them is it's like a big addition or big subtraction problem. I have to figure out if I'm going to add or subtract these for one of the variables to be eliminated. Well, I know I can add these, and I'll show you why. X plus 5x is 6x. Now negative 2y plus a positive 2y makes 0. So one of our variables is eliminated. And then negative 19 plus 1 is negative 18. So here we have 6x equals negative 18. Now you should know that x is going to end up equaling negative 3. And that's our whole goal, is to get rid of one of the variables by just adding or subtracting so that we just have one left over. And it almost looks like we're trying to find the x and y intercepts. Remember the cover-up method? It's kind of the same principle. We're trying to get rid of one of the variables by adding the two systems or subtracting the two systems. Alright, so now that I have x, I've got to substitute it back into one of the equations to find y. Now I'm going to find the easiest equation to do that with. So I'm probably going to use this one, just because it looks a little easier, a little simpler. You could use this one if you wanted to. Doesn't matter which one. So I'm going to use the first one. X minus 2y equals negative 19. So my x is negative 3. So I'm going to rewrite this without the parentheses. Negative 3 minus 2y equals negative 19. To get rid of the negative 3, I'm going to add 3 to both sides. Negative 2y equals negative 16. Divide both sides by negative 2, and you get y is equal to 8. So now we have both our variables. So the last step is to write our ordered pair. Negative 3, comma, 8. And that's the solution to the system. If we were to graph both of these equations, that's where it would cross the graph, right there. That's where they would intersect. Alright, let's go to the next one. Here's a little bit different one. If you look at both of these, they're both in standard form already, but if I add them, 3x plus negative 2x, it doesn't eliminate those x's. And then 4y plus 4y, that gives me 8y, so it doesn't eliminate that one either. So in this case, I would probably subtract because the 4y's are the same and they're both positive. So if I subtract one of them, it will go away. So let's try it. So I've rewritten the equations. Now I'm going to subtract both of them. So what's 3x minus negative 2x? Remember, when you have a minus and negative, it becomes positive. So 3x minus negative 2x becomes 5x. Now 4y minus 4y is 0. Cancels out. 18 minus 8 is 10. So we have 5x equal to 10, so you should know that x is going to equal 2. Now that we have x, we substitute it back into one of the equations. I'm going to use the first, actually I'm going to use the last one. Why not? Alright, here I've rewritten the equation. I'm going to plug my x in, my 2, and I get negative 2 times 2, which is negative 4, plus 4y equals 8. Add 4y to both sides. Not 4y, I'm sorry. Add 4 to both sides, and you get 4y equals 12. So you should know that y equals 3. So there's our ordered pair. 2, 3. It's pretty easy. Now one thing that you might be questioning, because I know somebody's going to ask this question, is do we always solve for x first? Do we always eliminate the y first? No, you just do whichever one's easier. It just happens to be that those were the same values, so all I had to do is subtract them for them to disappear. And sometimes it might be the x. So let's go on. Here's a little bit more difficult one. Now look, if I added these two equations, they're both in standard form, so we're good. If I added them, I would get 2x minus plus negative x, which would be 1x. It doesn't disappear. So y plus 3y would be 4y. So now I'm going to subtract it. Let's see if that works. 2x minus negative x gives me 3x. Y minus 3y is 2y. So it doesn't really work out. So I can't add or subtract these. And if you want to, you can actually try it out. Let me show you what I'm talking about. So here I'm going to subtract them real fast. 2x minus negative x would give me positive 3x. Y minus 3y would give me negative 2y. And then 3 minus negative 12 would give me 15. So nothing's been eliminated. It just gave me another equation. When we add them, we get 2x plus negative x gives me x. Y plus 3y gives me 4y. And 3 plus negative 12 gives me negative 9. So it doesn't really eliminate either one of those problems. So this one's a little bit confusing. Now, realistically, we'd probably use a matrix on this, and we'd already be done. But we have to know how to do it by hand. So let me show you how to do this one by hand. Alright, first you want to figure out how can I eliminate this. Now, I can multiply an equation by a number to every number, and I won't really change that equation. I just multiplied it by a number. Or I could divide every number by a number, and it won't change it. So I could actually multiply this by negative 3. That way my y's would cancel. I would have negative 3y plus 3y, which would be 0. Or I can multiply this by 2 so that I would get 2x plus negative 2x, which would give me 0. And I think that's the way I'm going to go. It looks a little bit easier than multiplying by a negative. So I'm going to multiply this whole thing by 2. And this is what I get. I get negative 2x plus 6y equals negative 12 because I multiplied every number in that equation by 2. It doesn't change the value of the equation. It's actually the same one. I just multiplied it by 2. Alright, now I can add these two equations. 2x plus negative 2x is 0, cancels out. Y plus 6y is 7y. 3 plus negative 24 is negative 21. Divide both sides by 7, and I get y is equal to negative 3. Now I substitute back into one of the equations. Pick either one. I'm going to pick this one right here. So negative x plus 3 times negative 3 equals negative 12. So I get negative x minus 9 equals negative 12. Add 9 to both sides. and I get negative x equals negative 3. So x is going to equal 3. So my ordered pair is 3 comma negative 3. That's it. It's a little bit more complicated, but it's really not that bad. That's it, folks.